All right, so we're back and we're ready for some more coding. Let's see what we've got. We've got 25,000 cells moving ever so slowly, even though we go turbo mode. And that is of course because every frame we have to move them, every frame we have to check if they're out of bounds. So let's try to optimize this, but I think we need to cut the amount anyway, so let's go for 1,000. Yeah, all right, still a bit laggy, but it's not that crazy. Let's see if we can first add the y-axis before we optimize. Perhaps we could find a way to only check those not in the center. But to check if they're in the center of the screen, we need to check them anyway. So perhaps it's not even possible. Or perhaps we can only check every 5 turn. Yeah, that could be it. Let's try to do that before we do the y-axis. Right, so let's do we need the mod and we need the there we go. So what we're going to do is to check whether or not I mod 10 is equal to 0, right? Which means we only check each 10th frame, and that makes sense because we're checking each pixel, right? There's 480 pixels, but these guys can actually move off screen. So what we're doing is we're not actually we're actually extending the canvas a bit outside by doing this, and when they're outside the canvas we don't we only check those outside of the canvas in a way, because they can reach like 249 in the x in to the right and minus 249 to the left before that we move them, which actually the center of each of these is what we look at, and that means that, let's say they're 5 pixels across or 10 pixels across. If they're 20 pixels across, then it would actually work the same. So let's just see if this is true, which means that it only happens every 10th time. We check boundaries, right? But we don't have the eye in that one, so we need to do it here, and I think that's fine. Let's try. All right, so it's kind of hard to see. Let's up the number of cells. All right, it's still laggy, but let's hang on. No, I think we need to, because this checks for all of them, right? And we set I to 0 there, which doesn't really work. So we need another counter. Let's just choose J, and let's set J to set J to 0 up here. We can move these to the background after a while. These don't need to be on this one. Sprites as code. and we change j by 1, but if j equals hang on, so we don't really need that. Of course we can potentially hit the max number of scratch, right? And that might be like 2 billion or something. But I don't think that's an issue for now, so we should be able to just do this, I think. And there we go. All right, let's see. All right, so we have an issue. They're coming back in waves now. Let's compare it to the one without. So let's make a copy of this one without all these niceties. Alright, so this is the original one. Yeah, that's really slow. And let's do the new one. Let's see. Yeah, that is better. But it kind of moves them in waves now, which is not what we want. But I have a fix for that. Alright, so when we move them, so let's say they are at plus 245. We would like them to go to negative 235, right? Which means we need to get the difference. So let's first calculate the additional steps they've taken that we haven't rendered. We can do that by taking the absolute value of their of the x position, and we subtract 240. So let's say they've either at minus 245 or 240, that doesn't matter, and we're left with 5. And we need to subtract that from those, right? So in the case of so let's make a variable, let's call it extra margin, or extra movement. Alright, so let's set extra movement to that. Alright, so let's say that we've got at this extra movement is 5, and we need to subtract that from that one, but that's negative, so we need to add it, right? So that is minus 240 plus the extra movement, and in this case we need to subtract it. So in essence we're making things better with this code, but this makes this code more advanced. So perhaps in the end it's not worth it, but we'll see. We should have copied this before, so we can compare as well. Alright, hang on. We don't need these anymore. No. Alright, so this was the original. There we go. Alright, and this is 240 minus the extra movement. Alright. And yeah, let's see. Well, they are. So when they hit the wall, they kind of. They stay there, and that's because of Scratch, right? Scratch has a built-in function, functionality that doesn't allow sprites to move too far, and I think it's stopping them, right? So if we were to change the 240 to something less, to avoid this, we'd be fine. So let's add this. Let's make it X, not padding. It is. It's 240, but we need to remove some padding. So let's call this X padding first. And then we'll make another one that's called X no padding. Horrible names. What can you do? Alright, so we need to add these at the top. Set X padding, let's put that to 5, and let's do no padding to 240 minus X padding. Alright, I think I'll move all of this stuff into the background now. That these do not need to be in this place. Let's do this. And when we're done with all of that, we can broadcast message. Spawn, I guess. Spawn cells, and it's going to the sprite, and when I receive spawn cells, we do this. Alright, so we've got the new value, which should be X no padding, and this is X no padding times -1. There we go, and X no padding times -1. Alright, no more magic numbers. Yeah, alright. Let's see. Well, it kind of works, but they're still disappearing at the they still disappear at the same time. And when there's so many, that becomes noticeable. I guess if we were to cut the amount of cells to, let's say, 500, well, that's really efficient. And there it goes, yeah. All right. And you wouldn't notice anything at all, right? So let's just see. I think this is good enough for now. But this is actually not ideal because no, this is not good at all because if we draw this as a function, right, as a graph, it goes like this: no compute, no compute, all of the compute, no compute, no compute, all of the compute, right? But we would rather have it be the average of all of these, right? Because if anything else hits those peaks, then it will be slower. So this won't work. We need to do this part inside the function. And I think I have an idea. But I think the basic idea works. Let's not even try to test it. I think we saw that it worked straight away. But let's so this one, change I by cell attributes count. This goes to the next cell in the list. But if we skip, let's say we skip one cell, right? So we do that, we take the times 2. That would work for optimizing it because we would only be rendering half of them, right? But we see that they are stuck, right? So that won't work. So we need a way to, hang on. Oh, yeah, I thought too many got stuck. So only half of them is supposed to get stuck. Yeah, so half of the cells get stuck now because we're skipping them. But if we skip different amounts of skips each time and make sure that all of the skips are done, I think we can do it. And so if we want if we want to spread the movement checking, if we want to spread that out, we can do that in the same way, in dividing it in 10 intervals by checking every 10th, but then adding each time, something. So the first time it goes through, it goes to every 10th one. And then when it starts the next time, it should not start at the first one. I should be one more than it actually is. No, that's next time it checks boundaries, which means we need to pass it something. There you go. And we need to add this pass number. That's a horrible name, but all right. So we need to pass it something, and we pass it J, and we change J by 1 each time. We can pass it J mod 10, and so which means that we'll pass it first time, we'll pass it 1, 2, 3, and then when we get to 9, we pass 0, right? And we set I to 0 at this point, but if we set it to J, we will start at different points each time, I think. Alright, so let's try a lower number, see what happens. No, alright, so I think my idea is correct, but I think I'm doing it wrong. So, alright, so let's try. Let's just think about it. This. It will check if J is the first time we would send 1 through, right? Because J is 1 and J mod 1 mod 10 is 1, and we set I to 1. But that's not good. We need to set I to 1 times the cell attributes count, I think. There we go. Yeah. Alright. Alright. This is good. Let's try upping the amount of cells. Alright. 5,000. And yeah. Alright, so if this works, we should be able to see it by changing this. Oh, we need this to be 10 as well. Let's see. Alright, so if we do this. This is the original one, right? Is that actually moving quicker? Let's try a really high number. It's hard to tell. Let's do. Now they get stuck, something's wrong. I think I have an idea. Well, let's just keep it at 10. I think 10 should be good. And let's do 1,000 cells. Yeah. None of them get stuck. We can actually look at this number here and see how long it takes for it to reach 1,000. Alright, so yeah.